All right, we're back. This is Calc C Notes to page 2, part 2. I said in the last one that I thought I was going to try to do this one again the way that we did the last one, but it seems to me that the whole point of this is really to find a pattern. If you find the pattern, to use the pattern. So what I'm going to do instead, also because I just don't want to do that again because it was terrible, I'm going to attempt to use the pattern that we think we found. So the pattern we think we found, I have to make this like kind of small, so I apologize. We think we found that it's the value of the nth derivative, then x minus the center to the nth power over n factorial. We think that's like the nth term of this thing. And it worked before, right? So we had the fifth derivative, 5 factorial, fifth power. And then we had the fourth derivative, 4 factorial, fourth power. Now, it's x minus the center, which was kind of obscured when we did this because the center was 0, so we lost all these like minus zeros. But it's going to be x minus the center. So let's see if that works out on this one. So to do it effectively, we're going to have to know the center. So the center, I don't know what I'm doing here. The center is going to be 2. Oh, I know what I was doing. I was looking for a highlighter. What a weirdo I am. Okay, so the center is going to be 2, which means we're always going to get x minus 2's. So the issue, we think we should get the nth derivative. I'm going to call the center a, at a, x minus a to the n over n factorial. We think that every term looks like that. So some things that we would need to know to be able to do this, 0 factorial is defined to be 1. And I think that's actually the only thing we would need to know. So let's see if we can do this. And then what I'll do is I'm just going to check it on the calculator and see if it worked. So I'm going to say that p of x. So I know that this isn't really doing what the notes say to do, but whatever, they're my notes. Let's vary it up. So p of x, I think the 0th derivative. So the 0th derivative at 2 is 1. So it's going to be 1. Then it's going to be x minus the center to the 0th power over 0 factorial. That term looks really weird, and I'm telling you, we're right. I mean, we got this right. It always looks weird. Most people don't write it, but I like to write it because it fits the pattern. Plus, we need the first derivative at the center. So it's going to be -3. And then x minus the center to the first power over 1 factorial, which again, most people don't write that part, but I think it's good, plus the second derivative. It's annoying that that's 2. The second derivative at the center, which is going to be 2, x minus the center to the second power over 2 factorial, plus the third derivative at the center, x minus the center to the third power over 3 factorial. This is one of those things in math where it's like we're lucky that it's as easy as it is, or as simple as it is, I guess. It's not really easy. But the pattern works so nicely. Plus, so the fourth derivative at the center, x minus the center to the 4th power over 4 factorial, plus the 5th derivative at the center, x minus the center to the 5th power over 5 factorial. So how would I really have written this? I really would have written this as p of x is 1 minus 3 x minus 2 plus. So you do leave the factorials, which it drives me insane that a lot of people are unwilling to do that, but you do it. So you pull out that minus. So just leave your factorials. Nobody expands them. It's not a thing you do. The calculator is going to do it, but there's just no talking to the calculator. It just does what it does. If you leave them, it's very easy to see the patterns in this pattern, and that's what we want. Also, it reminds me, think back to math analysis with, I'm talking specifically to my students right now, but maybe you've done my math analysis notes. The parametric equations, like when we're writing parametric equations for lines and all, you didn't want to simplify things because if you simplified, you like lost all sense of time. Here, you lose the pattern if you simplify. So this is going to be our 5th degree polynomial. What I'm going to do now is what am I going to do? Because I don't want to type that. I guess I'm typing that. I'm going to type that into the calculator. No matter how you do this, you end up regretting it. I'm going to type this into the calculator and then go from there. So, all right. So I feel like there's something I could do that would be really clever to make this work, but it's probably not worth it. I was gonna like put all the things in like a list and then like call them out of the list, but I don't know. So like I don't need to be developing my programming skills like at this exact moment while I try to just type this in, because it's not really that bad. It'd be pretty bad for you though, because if you're using the handheld, which like I don't know if you are. Actually, no matter what, it's not that great right now. Here we go, 4 factorial. The one thing that's nice is the pattern. So at least I know what I'm doing. To the 5th over 5 factorial. All right, this is P of X. So the real moment of truth here is we want to find like nth derivatives. So I want the 5th, so X, I want the 5th derivative of P of X, and I need to evaluate it at X equals 2, and I should get negative 20, and I do. Let's try the 4th derivative. Let's actually make this, let's make this n. And then we can do X equals 2 and n equals, and we'll do 4, and it should give me 8. We'll do 3, and it should give me negative 4. 2 should give me 2. 1 should give me negative 3. And the 0th derivative is the original function, which the calculator is smart enough to know. Gives me 1, which is exactly what I wanted. So it definitely works. So I decided to use the pattern. If you would prefer to integrate, I can't imagine that. I mean, I guess there's someone out there who wants to do it. Go ahead and do that. But you're going to get this. It fits the pattern that we thought we had. So we think, and we're right, that the nth term should be the nth derivative at the center, x minus the center to the nth power over n factorial. All of those are n, and that's crucial because it just makes it so easy to remember, really. So, all right, I'm going to end this here. This one hopefully is a lot shorter because we took this little shortcut. I'm not really convinced that it is, but hopefully it is. So I can't figure out how to stop it. Oh, here we go. All right. So I will see you in the next video where I assume we will just keep going with this idea. So see you there.